Now right here, we're going to solve the number 2. We had it to be 4x minus 1 divided by 3x plus 1. So find the domain of this function right here. Well, now we have the numerator to be a polynomial function and the denominator as well, a polynomial function. But this function right here will have some restrictions. Okay, that's why you're actually looking for the domain. The restriction is that the denominator should not be 0. Okay, so the denominator of this function, that is 3x plus 1, should not be equal to 0. Should not be 0. Very good. Okay, that means if we assume, or if we let the denominator to be 0, the whole of this will not have a solution, or will not have a defined value. Now, how are we going to get the values of x for which this denominator will get equal 0, so that we do away with them and we take the rest to be our values? Well, from here, this, should I say, inequation, yeah, from this inequation, because it's not an equation, I'm just saying it should not be equal to 0. So I'm going to say let's just solve it like this, alright? Very nice. So you will not see them solve like this anywhere. Let's just solve it like this and take out the values we don't want. We have that 3x should not be equal to negative 1. That is, you subtract 1 from both sides. So like moving 1 to here to turn to negative 1. So 3x should not be negative 1. That simply means that x should not be negative 1 over 3. So with this value now, the whole of this is going to be undefined, or it's going to tend to 0. So x should not be negative 1 over 3. That is to say, x can be every other thing, but not negative 1 over 3. So the domain of x is just going to become domain of this function, that is the value of x for which this function will define, is just going to become negative infinity till negative 1 over 3. Open at that point, that is to say we don't include it, alright? And it's always open at infinity. That is increasing without bounds, so we can't close it, alright? And it should unite with, well, we still open it again, negative 1 over 3, and we take it to positive infinity, like this. So we don't choose this. This open interval shows that the edges are not chosen, alright? The edges are not chosen. We are only using this because we want to get all real numbers. We don't just want to get whole numbers. We want to get all real numbers for which this function is going to be defined. So we open it at negative 1 over 3, we don't choose that point. We open it at negative 1 over 3, we don't choose that point. So the union of this and this is the stuff right there, the domain. Take note, like I'm saying, this and this are not included. If we were to include negative 1 over 3, I would have said close it at negative 1 over 3. It will start at that point, negative 1 over 3, that is negative 0.33333 to the right. But since I'm opening it, it will start from a number after negative 1 over 3, which could be 0.33334. But 3 increases, so it doesn't terminate. Okay, so that is the domain of this other function. We can go on to number 3 real quick. We have cube root of x squared minus 9. What is the domain of this right here? In fact, the domain of this right here is the set of all real numbers. Why? Well, this is a cube root. It's unlike the square root or even root. For the cube root function, the negative, if the radicand is negative, we still have a real value. For example, what is the cube root of negative 8? Cube root of negative 8. Well, we can have a number negative 2 such that negative 2 times negative 2 times negative 2 again is going to give us negative 8. Therefore, the cube root of negative 8 is negative 2. So, for the cube root like that, we always have the radicand to either be 0, greater than 0, or less than 0, which is pretty much like the set of real numbers. Therefore, x should belong to the set of real numbers. This right here is the domain of the function. Here I would have said x should belong to all of this. Okay, x should belong to all of this, like this, the union of this and this. Alright, and over to the fourth one. Well, this we're going to solve it in the next video. So I believe this is helpful enough, and this as well. Over to the next one, which is shown on the screen. Just click it and make sure you subscribe to this channel.